All right, so now we're moving on to section B of our chapter 6, and this is going to be rational equations. All right, and what rational equations means is it means fractions. All right, so we're now going to be dealing with rational equations or fractions where we have a variable that is in either our denominator or our numerator, and it is a rational equation, meaning we have a variable in our denominator or our numerator, and it's a fraction, right? And this section is actually being broken up into two different videos. The first video that we're doing right now is going to solve the objective number 1, and that's to solve rational equations through cross multiplying. All right, by using our least common multiple, we'll do that in the next video. For right now, we're just going to solve rational equations through cross multiplying. All right, so let's go ahead and do a couple, talk about a couple things first before we do any examples. All right, the first thing we're going to talk about is if I give you two fractions and they're equal. 2 over 3 is equal to 2 over 3. We know that. One of the ways that we can check to see if they are equal is that we can multiply one of our numerators with the opposite denominator. So we can multiply across 2 times 3, and that is equal to 6. And then we multiply the other numerator with the other denominator. We cross multiply again, and 2 times 3 is also equal to 6. So if our fractions are equal and we don't have anything being added or subtracted out here, and it's just two fractions that are just equal to each other, we can simply just cross multiply. And we know that they're equal, right? Same thing. If I give you 2 over 3 and I say it's equal to 4 over 6, we know that these are equal because we can actually reduce 4 over 6. But we can check by multiplying our opposite numerator and our opposite denominator. So 4 times 3 gives me 12. And then we can multiply our opposite numerator with our opposite denominator. So 2 times 6 is also equal to 12. So as long as if our fractions are equal, we can simply cross multiply, and we use this to solve. All right, so let's go through a couple examples thinking about this. All right, so the first example is 4 over x is equal to 3 over 4. All right, now if we're trying to solve for this, unlike the other ones where we could actually reduce the 4 over 6 to see if they are the same, we can't reduce this because we don't know what x is. But what we can do when we have two fractions that are equal, this is actually called a proportion, but we can multiply our numerator with the opposite denominator. So 4 times 4. And then we can multiply the other numerator with the other denominator, which is then equal to 3 times x. Then we go ahead and simplify. 16 is equal to 3x. Let me write that a little bit neater. 16 is equal to 3x. And now we just solve because now we have a regular linear equation. Right? And we can simply solve this by doing our inverse operations. And the inverse operation multiplication is division. That will cancel out here. So we're left with x is equal to 16 over 3. Right? And then if you want, you can go ahead and substitute this in to see if it is going to give you the same value. And that is what x is equal to in this example. Right, now we're moving on to our next example. All right, so now you notice every time we're multiplying before I put them in parentheses, and it's important you do that, especially in this one here, because if you see we have two terms in our numerator. So when we go to cross multiply here, you must put this in parentheses, the one with the two terms, because this 2 needs to be multiplied not only to the 3, but also to the x as well. So make sure you're putting that in parentheses. Right? Then we do our other numerator with our other denominator. We also cross multiply here. So then we can say is equal to x times 5. All right, now we go ahead and simplify. We can distribute the 2 in to both, so we get 6 plus 2x, and then we just multiply x times 5 is equal to 5x. All right, now we have a linear equation. But now we have a variable on both sides, so now we need to go ahead and move our variables to one side and our constants to the other. Since our constants are already here by itself, I'm going to move this variable to the other side. So I can subtract our variable, because that's its inverse operation of the addition, and it will completely remove it. And what I do to one side, I have to do to the other. So 6 is then equal to 3x. And now we go ahead and we divide each side by 3 because we have our linear equation, so we're performing our inverse operation, and we get x is equal to 2. All right, if we want to check our answer, we can plug it back into the original problem. Right, now this is actually the last example that we are going to do in this video, but this one is one to go through because it has two terms in each of our numerator and our denominator. So same thing, since we had two fractions equal to each other is a proportion, we can multiply our numerator with our opposite denominator, So we can then say, and remember, make sure you're writing it in parentheses, so 3 times 3 minus x. And then we could do the other numerator with the other denominator, cross multiply. So that is then equal to 4 times 2x plus 1. And then we're going to go ahead and just simplify. We distribute this 3 in, so we get 9 minus 3x. We distribute the 4 in, so we get is equal to 8x. Distribute the 4 in as well, plus 4. Right, now we have variables and numbers on both sides. It doesn't matter which way you move this. You pick. Right, so now I'm just going to go ahead, since I have more x's on this side, I'm just going to move this 3x to the other side, just so that way I have my x to be positive, because I don't want to divide by a negative number. And then I get 9 is equal to 11x plus 4. Right, now we are going to go ahead and we're going to move our constants to the other side, because we need our constants on one side. So our inverse operation, so we then move our 4 to the other side. So now we get 5 is equal to 11x. And then the last thing that we need to do to isolate our x is we do our last inverse operation, and we get that x is equal to 5 over 11. And once again, if you want to check to see if this is correct, you can just plug this x is equal to 5 over 11 back into your original example and see, did we get our fractions equal to each other? All right, so that is it for this video. This section, like I said, is broken up into 2 different days, but that is it that you need to watch today.